This is a problem that might look familiar to you because we did it a few videos back, and we know 3 different ways you could do this problem. You could graph them, see where they cross. You could get a variable by itself, toss it in the other equation and do substitution. Or you could just do the thing where you multiply by number, try to add, mix, and then cancel, our elimination method. All perfectly good options. However, using technology, using our calculator to help us out, often makes problems quicker, especially after we've already learned how to do them. This method that you're going to see in this video will seem probably a little like, some of you are probably going to think, I don't want to be able to have to do this. I already know a couple ways of doing this. I got this. I don't need it. Which is fair. But it really is an issue of convenience. After you learn this, it's fastest, it's easiest, and it's really, when you have bigger things to be worrying about in problems than just solving a little system, it's a quick, convenient way to get it done. So anyway, we learned in our last video how to write this guy as a matrix equation, and I'm going to write down my answer in just a second, but you should go ahead and try it too on your own. Remember, coefficients go on the left. Then we have our variables, and then we have our answer over on the right side. And I'm going to go ahead and give the 2 matrices with numbers in them a variable. What I mean by that, I'm going to call this guy right here matrix A, and this guy over here matrix B. A is going to be your coefficients. You'll see me use A and B a lot. So A is usually, well, in our context, it'll be the coefficient matrix. B is the answers. It's the numbers by themselves. What would be really nice in this problem is if we could get rid of this matrix right here, get rid of matrix A. If we just had this as our answer, whatever's left right here. Remember, equal matrices, X would equal to 12, and Y would equal negative 85. So if that was just what you had, you would have X equals 12, Y equals negative 85. However, this matrix right here is kind of messing things up for us. So what we can do right here, what we want to do, is cancel this matrix out somehow. Now you could say, well, why don't you divide that matrix both sides and just get rid of it somehow like that, like you would with regular numbers. But remember, you can't divide by a matrix. So what you have to do here is multiply by the inverse of this matrix. Whatever the inverse is that's going to cancel it out, that's what we want to multiply by. So we're going to multiply by the inverse, and if we do it on one side, we have to do it to the other side as well. So whatever the inverse is, we're not going to worry about it. They would cancel out, and all you'd have left is X and Y. And on this side, you will have this little equation here, A inverse B. If that little explanation didn't make sense, this part right here is key, knowing just A inverse B. Finding an inverse by hand is not terribly fun to do. I didn't even show you guys in the video because we're just going to do it via technology. But this little phrase right here, A inverse B, is going to be the key to doing our problems. In the next video, I'm going to show you guys how you can take this same problem. Well, I'm kind of breaking this video into 2 parts here. Take this same problem and use your calculator to get the answer.